Hello, and welcome back to the video lecture series for Introduction to Data Programming using Scala. In this video, we continue talking about our ADTs of arrays and stacks. In particular, we're going to work on a stack. And we're going to take it from the abstract, we're going to actually make a concrete implementation. And as this tells you, we're going to make our concrete implementation using an array. In a later chapter, we will make use of the abstract part, and we will write a completely different stack, same operations, but they'll be implemented differently using a linked list. But for this one, we just want to focus on an array. So, I have created a class here called an array stack. Our array stack extends my stack, and it has the 4 operations that are in here. Okay. Now, in addition to these 4 operations, we're going to have to implement these. We also have to figure out what additional information we're going to store. And as the name implies, we're using an array. So you can picture an array. This could be like, assuming A was of type int, A can be whatever type we want, but if it were ints, because they're easy for me to type, this might be an array with 5 elements in it. And the question is, when I push something onto this, where does it go? And the answer to this kind of depends upon where you are, what you consider to be the top of the stack. I want to start off by having this first element be the top of the stack. So I'm using a little caret here to represent. Let's go ahead and see if comments will get rid of some of those red underlines. Okay, so I'm going to consider this end to be the top of the stack. I have a little pointer there, and so when I push onto the stack, it goes there. What should happen to my arrow? Well, I guess you could say I move it to there. Okay, so now that's the top of my stack. Now the question is, what happens when I push something else? And sometimes students are tempted to say, well, you put it back at this end, then you move the 5 down. But that would break my order 1 requirement, because remember, I'm supposed to get the same performance no matter how many things there are. Imagine there are 1 billion elements on here, and you want to push at this end. Well, then you have to copy all 1 billion of them down. Clearly, that's not order 1. That's actually order n. So I can't do that. Instead, I'm just going to place the new value right here. So let's say the new value was a 2, and then my top moves. So this arrow top is just simply an int as an index into my array, and my array stores the values. What happens when we pop off? Well, when we pop, this gets decremented, and we return the value that's located there. Okay, so this is what I need to implement inside of here. I need to have an array, and I'm going to make it private. We'll start off making it a val. That's how we do things. And how about we call it data? And data is going to be equal to, I'm going to make a new array of type A, and I'll start off saying, let's put 10 elements on here. In addition to that, I want to have a private, now this I know is going to change, var top, and start off at 0. Okay, so that top represents my little arrow, the data represents this array, and we need to figure out what's unhappy here. So we have this error, and it says, cannot find class manifest type A. This error would be rather confusing to a novice programmer. The problem is, it turns out, so when I create an array, it needs to be filled with the default value. So if I create an array of ints, it needs to be filled with zeros. If I create an array of doubles, it needs to be filled with 0.0s. If I create an array of strings, they're filled with null. In fact, anything that's any ref would be filled with null. But they would need to be filled with different things. And it turns out that the Scala doesn't know by default what it is, because A is just too general. I haven't told it anything. And so to correct this, I need to tell Scala that A has a manifest. And there's some syntactic sugar that's going on in the background that we don't really care about here. But this makes it so that we can create arrays of this type. And in general, when we need something that's going to be array-based and it has a type parameter on it, we're going to be doing exactly that. So now we need to implement our 4 methods. And the way I do this with my students, I'm like, let's start with the easy methods. That way we'll feel successful early on. Okay? Which one of these methods is the easiest? Well, I would argue it's is empty. When is the stack empty? Well, the stack is empty if this arrow is all the way back at the beginning. So we're empty when top is 0. And if top's not 0, we're not empty. Okay, so hey, that one's done. Yay. Doesn't that make you feel successful? Peak. Okay, peak is supposed to give us back the value that we would pop without actually popping it off. So what should this do? What value should we give back? So let's think of when I had my situation here. I had pushed a 5, I had pushed the 2, top is here. When I want to peak, I should return the 2. Well, that's being pulled out of data, and it's not at top, it's at top minus 1. Okay. One might ask sorry, gosh, I'm definitely doing too much C++ programming, mixing up my languages here. C++, you index arrays with square brackets. In Scala, the square brackets are only used for type parameters. Okay, so I give back the value at top minus 1. Push and pop. Okay, what about these? I think actually push, at least originally, will be a little bit easier for us. I can implement push as saying that data sub top equals O, top plus equals 1. So consider this picture. If I were to push a 3, I store a 3 at the location of top, and then top moves over. And that's what that code does. And then last we have a pop. And the pop is supposed to give us back this data value, but it's also supposed to move the top back 1. Okay, so how do we do this? Well, first I'm actually going to make a new val. I'm going to call it ret. It's the variable name I like to use for something that is actually no, wait, I don't need a ret here. I would if I'm going to clear things out. Turns out that the clearing out, because we have type A, I don't know what this should be, can be a little bit more challenging. Maybe we should come back and revisit how we would do that, because you can actually have some subtle resource leaks if you don't clear out your data structures. But this will suffice for us now. I decrement top, and then I return the value that's at the top. And then the next time that we push, we will overwrite that value with the new thing that we've pushed and increment top again. So, in many ways, this looks like a perfectly happy little implementation of our array stack. And in many ways, actually, this could pass quite a few tests. It will work very nicely, except for we have one minor problem, and that is the fact that it only stores 10 elements. So if we were to do some testing of this, we would find as soon as we try to push the 11th thing onto our stack, this code will crash. And so we'll come back in the next video and we will look at writing the tests for this and also then fix the fact that we can't push too many items onto it.